This video deals with the topic of predictive tools for completing the text based on the user input. We will first look at the T9 system that allowed users to type faster on phones with numerical keyboards. Then we looked at autocomplete functions on modern smartphones. Finally, we look at coding, where predictive text is not necessarily only text, but it can also be chunks of computer code. We will focus on the overlook of the topic, on practical applications, and possible issues and challenges. In the 90s and early 2000s, cell phones were using numerical keypads for input. To write a word hello using the keypad, one has to press twice 4, twice 3, 3 times 5, wait a bit, again 3 times 5, and then 3 times 6. Now remember, if you had a phone like that, how long it took to compose a lengthy SMS. The T9 predictive text algorithm was developed to recognize the word that the user was typing from a sequence of numbers. So, if the user typed 43550, the system would recognize this as hello. Of course, other possibilities existed, so a menu would pop up to choose possible words from several options. The key sequence 4663 on the telephone keypad, provided with the linguistic database in English, will generally be disambiguated as the word good, but it could also mean home, gone, hoof, or hood. Today, a T9-like approach is still used, for example, for quickly searching the contact list on the phone. While some early phones already had a full keyboard, remember BlackBerry? It was the smartphones with touchscreens that truly popularized full-sized keyboards. For computers, keyboards have been the way of text input since the very beginning, and the same for typewriters, but typewriters are mechanical, so we cannot really talk about algorithms to support typing in those cases. There are two immediate applications where you couple text input with artificial intelligence. One is autocomplete, where the system predicts what word you are typing, and this speeds up the writing process. This is of course particularly helpful with phones where 10-finger blind typing is not a thing, as opposed to a computer keyboard. The other one is autocorrect, where the system recognizes that a word is spelled incorrectly and fixes it. These functionalities are integrated in a wide series of applications, such as in smart keyboards for phones, and as spelling and also grammar checkers in MS Word and related text editors. Some mobile keyboards allow users to type by sliding their finger from letter to letter. The system then uses complex algorithms to predict the word based on the gesture pattern. The approach with writing a text and autocompleting or autocorrecting it on the fly is not limited only to writing text. It can be used in writing more complex things, such as computer code. Intelligent code completion is a powerful tool in modern software development, assisting developers in producing code quickly and with fewer errors. An example of this tool is IntelliSense. It works by analyzing the code context, available libraries, and other factors to offer contextually relevant suggestions. Some of the functionalities it has, of course beyond autocorrect and autocomplete, include displaying the parameters expected by a function or method, showing a list of properties and methods related to a particular object, and syntax highlighting and error indication, which helps in identifying issues in real time. There are many algorithms that are used in predictive text and intelligent code completion. Let us mention some of them. Predictive text relies on extensive built-in dictionary that holds a vast number of words. As the user types, the system scans this dictionary for words that match the entered characters. Over time, the system learns from the user's typing habits prioritizing words that are used more frequently. Some systems also allow the addition of new words to the dictionary. Systems may employ n-gram models or other statistical analysis to predict not only the completion of the current word, but also the next word in a sentence. Other approaches include typing patterns, context awareness, collaborative filtering, and heuristics. Predictive text can significantly speed up typing, especially on devices where typing might be slower due to size or interface constraints. It can reduce typos and improve the accuracy of the entered text, help people unfamiliar with certain words or spellings, and people with disabilities that might make typing challenging. In coding, developers can write code faster and with fewer interruptions to search for method names or parameter requirements. By suggesting variable names and methods, code completion tools can help maintain coding standards and consistency. Finally, they allow on-the-fly learning with suggesting specific libraries and frameworks to the users not familiar with them. On the other hand, there are some drawbacks. Sometimes, or maybe often, predictive text might suggest incorrect or inappropriate words, leading to confusion or miscommunications. Oh, autocorrect, sorry. In coding, over-reliance on code completion could hinder the learning process, especially for beginners who might not take time to understand the suggestions fully. By always taking suggestions, users might find their writing or coding becoming more generic, potentially stifling individual creativity or unique coding solutions. Finally, there are privacy concerns, as some predictive systems send data to external servers. This can lead to inadvertently sharing sensitive or proprietary data with third parties. At the end of the unit, you'll find several questions to test your knowledge. Here is one of the questions. How might predictive tools affect the user's writing style over time? By making it more personalized, by making it more generic due to constant suggestions, or maybe by increasing the vocabulary extensively, or by reducing the total word count. What do you think?